Okay, so what you're seeing here is this is the level 5 trihexyl Holon, the RGB color Holon, and basically what I've done here is I've created two different layers. One layer uses linear dodge, that's adding, and one layer uses linear burn, that's subtracting. Both of these layers have on them, let's just see what's on the layer, is blue and red. So this is what I was talking about in the second blog post. The blue and the red channels of color data that's coming up from the smallest one here all the way to the biggest level, or all the way to the largest level, from L5 all the way down to L0, which is the entire thing. Okay, so let's see what happens when we take this original color image with the green and we do a subtraction or a linear burn. Obviously, if I were to take this, so this is a filter. This is the filtered view of what it looks like, and this is an XOR logic gate, because what it's doing is it's saying, I'll just pull that on and off here for a second. What it's doing is it's saying everything that's underneath this. Now, obviously, I'm doing an XOR on the data itself, so if we were to take this, and let's just say we're going to do addition, right? All right, so linear dodge, right? I added on the linear dodge, and what it does is it actually compresses all of the colors along the space to be within some specific palette that doesn't, like, along the color dimensions. Let's see how many colors are in here. 1, that's red, blue, green, right? Then there's orange, well, slightly more orange. In fact, let me just take this out here. Let's do it this way. And let's see, so we can see it here. Alright, so we'll skip red for a second. We've got blue at 255, right? Green is at 128 because we're not actually including green. So technically, green still has the gradient, as you can see here. But when blue is involved, it just turns into a complete total same color, because this blue and the red are adding to the other blues through the red-blue filter. As you can also see, the resolution on the magenta here, it disappears on this last final level for lack of green. But if you can see on this last final level for blue-green, you can still see a color difference between the final level of color and the adjoining levels outward. So this is an interesting thing because, okay, let's see, we've got green at 50% brightness, green, so this still works the same way, right? But this is blue at 100% brightness, blue at 100% brightness, blue at 100%, and all of this, these mountain range over here is split up into blue at 100% brightness and magenta at 100% brightness. And red is also the same. But green maintains its gradients, although when it has to deal with blue and red So in the first blue-red holarchy of green, we've got this light violet color, right? And it goes throughout the whole holarchy, unlike the blue-green version of green and the red-green version of green, which is yellow to orange. So we can still see yellow to orange, and we can even still see green's influence on the outer levels of each of these smaller and smaller triangles through the other ones. So that's using de-dimensionalizing the data channels, so that you turn this filter, adding it back to the original image, you get that. And I'm assuming the same goes for the red-green filter, the blue-green filter as well.